You know, missing a single grade boundary because of a simple, careless error, it's honestly one of the most frustrating things that can happen in an exam, especially when you actually know the math. You've studied the theory, you totally understand how computers work, but under the pressure of that ticking clock, your marks just kind of slip away. Well, today, we are putting an end to that. We're going to take your Cambridge IGCSE computer science exam technique from completely flawed to absolutely flawless.
Let's look at this exact question. Convert hexadecimal 7a into denary. Show you're working out. Now, this takes what, maybe 3 seconds to read, but I'm telling you, it completely shatters the confidence of thousands of students every single year. So, do you know the answer? And honestly, more importantly, do you know exactly how to secure every single mark the examiner is secretly holding back?
Because here is the painful reality of exam day. First, you've got your typical 0-mark student answer. You know, they might even guess a number that's super close to the truth or try doing the math in their head, but they just write down a final figure. Then, compare that to a full marks top band answer. It doesn't just show the final number, it maps out the exact binary translation steps. Ordinary rushed revision completely falls apart under pressure because it ignores the actual process. Bottom line, if you skip the working out, you are literally throwing away free marks.
Section 1. The Denary Exam Trap.
Okay, let's dive into this first major pitfall, because this is the core reason the examiner traps so many students. The Cambridge exam strategy strictly states, for calculate or show command words, you must show working. 1 mark needs 1 distinct technical point. The command word show is a massive, massive trap. If you see show you're working, it is a mandate. Even if your final answer is 100% correct, if you provide 0 working out, you will score 0 marks. Just let that sink in for a second. The examiner isn't just testing your math, they are testing your transparent logic.
Section 2. The binary bridge method. So, the big question is, how do we guarantee our logic is perfectly visible on the page? Well, we use what I call the binary bridge method. But before we cross that bridge, let's make sure our foundation is rock solid. Hexadecimal is a base 16 number system used by computers for processing. It's actually pretty similar to our everyday Denary system because it begins with the digits 0 through 9, but then it shifts gears, using the letters A through F to represent 10 through 15.
And this brilliantly illustrates the exact translation between all 3 systems. We've got denary, hex, and 4-bit binary all lined up. You absolutely need to memorize this exact 16-row table. It is your ultimate quick win cheat sheet. Just notice how denary 10 becomes hex A, which is binary 1010, and denary 15 becomes hex F, or 1111 in binary. Seriously, if you can just quickly sketch this out in the margins of your exam paper as soon as you sit down, you've already won half the battle.
Section 3. Combining nibbles into bytes. Now, the exam is never just going to ask you to convert a simple single digit. Let's look at a slightly larger target number, 16. This is where we really start to apply the binary bridge mechanism to something larger than 15. How do we turn denary 16 into a hexadecimal format without completely losing track?
Well, we follow these 3 exact steps. Step 1, convert your denary number to an 8-bit binary byte. So, the number 16 in binary is 00010000. Step 2, you split that 8-bit byte right down the middle into 2 4-bit nibbles. That gives us 0001 on one side and 0000 on the other. Finally, step 3, translate each nibble individually into a hex digit using our cheat sheet. The 0001 is a 1 in hex. The 000 is a 0 in hex. Combine them and boom! Denary 16 beautifully becomes hexadecimal 10. See, you just crossed the binary bridge.
But wait, there is a huge examiner clue hidden in these questions that changes the answer and honestly how you should structure it completely. If you miss this, the binary bridge won't even save you. I'm going to reveal exactly what that clue is in just a moment, but first we need to make absolutely sure our framework works in reverse.
Let's move to and see how this builds when we completely flip the script. Take the hexadecimal number 3C. If the exam asks you to convert a hexadecimal number back into denary, this reverse logic scenario applies perfectly.
We literally just walk the bridge backward. Step 1. Separate those hex digits into 3 and C. Step 2. Convert them into binary nibbles. Hex 3 is 0011. Hex C, which remember is 12 in denary, is 1100. Step 3. Combine them back into a full 8-bit byte. That gives us 0011,
1110. And step 4, just use the standard place value method to find your final Denary number. The mathematical symmetry here is honestly just deeply satisfying.
So let's execute that final place value step to prove it. We take our byte, 00111100. We lay it under our place values, 128, 64, 32, 16, 8, 4, 2, and 1. We have ones turned on under the 32, 16, 8, and 4. Now, simply add those up. 32 plus 16 is 48, plus 8 is 56, plus 4 is exactly 60. So hex 3c equals Denary 60. And the best part? You've shown every single step, leaving absolutely zero doubt for the examiner.
Section 4. High Mark Answer Framework. All right, now we pivot to the psychological aspect of the exam. Remember that open loop I mentioned? That hidden clue? Well, here it is. The clue is the command word itself. It dictates exactly how much working out is actually required. If a question says state or define, it just wants a concise fact. Easy. But if the question says show or calculate, it mandates a visible working out process. If you treat a show question like a state question, you lose. The wording isn't just a friendly suggestion, guys. It is literally the rulebook.
So what is the ultimate template that guarantees top band marks? It really relies on structuring your response exactly how the mark scheme expects it. First, the concept. Clearly identify what it is you're converting. Second, evidence or data. Write down those binary nibbles. Third, scientific reasoning. Show the addition of the place values or the combination of those nibbles. And finally, examiner wording. State your final answer clearly, making sure it matches the exact format asked for in the prompt. This framework makes your answer entirely bulletproof.
Section 5. Final Exam Challenge. All right, it's time to raise the stakes one last time. Here is your challenge. Convert the Denary number 75 into hexadecimal. I want you to literally pause this explainer right now, grab a scrap piece of paper, and physically write down your working out using the binary bridge method. Don't just do it in your head. Prove it on paper. Go ahead. Pause now.
Okay, you're back. Now, what's really interesting about this slide is seeing exactly how a top-tier paper looks when the examiner's red pen comes out. To get 75, we need the 64, 8, 2, and 1 bits turned on. So our binary byte is 01001011. We split that into two nibbles, 0100 and 1011. The 0100 translates to the number 4 in hex. The 1011 translates to 11 in Denary, which of course is the letter B in hex. Combine them and you get 4B. If your paper looks like this table, you just scored full marks. Incredible job. Let's escalate the challenge immediately, just to ensure this concept is entirely cemented in your mind. Convert the hexadecimal number 5F into Denary, using binary to help you. This is your classic reverse conversion. Just think about the steps. Separate, convert to binary, combine, add your place values. And here is your flawless examiner-style correction. First, separate the 5 and the F. Convert the 5 to the nibble 0101. Convert the F to the nibble 1111. Combine them into your full 8-bit byte 01011111. Finally, apply those place values. We just add 64, 16, 8, 4, 2, and 1 all together. The math gives us exactly 95. By systematically writing out these points, you have completely transformed what could be a really confusing calculation into an absolute guaranteed win.
So the crucial point here is mastering this method isn't just about the math. It's about strategy and it's about practice. To ensure you have every single strategy you need, make sure you subscribe to AC Exams at the handle acedexams_IGCSE to really excel in your Cambridge examinations. It is basically the required next step for your revision journey. So you can convert back and forth flawlessly now, right? But wait, what happens when your data storage runs out of bytes entirely? Like, what do you do when the files get way too massive for the memory? Well, you'll need compression. And understanding how lossy and lossless compression actually manipulate these very binary bytes, that is the difference between an A and an A star. You absolutely need to know how that works, which makes our next explainer an absolute necessity to click. I'll see you there.